All right. Here's some even answers. I am going to look in here, page 399. All right, 5, 6, 7, and 8. Every rational function. Okay, so 5 should be false. We actually did one in class where it did not have a vertical asymptote. True. Every rational function has at most one horizontal asymptote. That would be true. You cannot, on the far left and the far right, it cannot be approaching two different values. It can be approaching the same value. So that would be true. And then 7 is false, 8 is true. Okay, for those, and we talked about yesterday, you can cross a horizontal asymptote. Okay, and then we didn't come up with a case yet. We will today for that one. All right, understanding like 17 through 26, that's all that as x approaches like 1 from the right or as x approaches 1 from the left. Where's f of x going? Is it going to infinity or negative infinity? All that good stuff. But mainly, I think, how about 41? I want to take a look at that one. All right, 41. Who has, does anybody have the original function handy? Who's going to need that?
Squared.
All right, hold on. F of x equals x squared, okay?
Minus 6x.
Minus 6x
Plus 8.
plus 8
Over x squared. Minus x. Minus 12.
All right, Anna, what do we got to do? I'm distracted. Find if we're looking for the vertical asymptotes. All right. So anybody, what do we got to do? Oh, now it's back in.
Sorry, factor the denominator.
And you know what? Tell you what that will give us, but we also want to factor the numerator because that'll affect it as well. Okay, so you do if they both factor them both. Because does anybody know what the answer to this one is, Andrew?
The factor, the actual answer.
Final answer for the vertical asymptotes.
It's y equals -3.
X equals -3. So yeah, and it's just x equals -3. I bet you some of you have two answers. You gotta make sure you answer why it's only one. So when you factor this, you get x minus 4 times x x minus 2 over x minus 4 times x plus 3. So right now you say, oh, 4 and -3 are my two vertical asymptotes. But what happens to the x minus 4 in the numerator and denominator? They can both cancel. When that happens, and this is acting up. When that happens, you do not have a vertical asymptote. What will you actually have at that spot? You have a hole. You have a hole in the graph. Okay, yep. Donut. So that's still not in the domain. So if they ask for the domain, it would not include 4 and -3. But for our vertical asymptotes, okay, that is just going to be x equals -3. Okay, x equals -3, and then you're done. Okay, so now. All right, horizontal asymptotes, starting with what's the first? Just 45 and 47, right? Mm-hmm. All right, we'll talk a little bit about more of those, but let's at least hit those. 45, Andrew, you got the equation?
X plus 1 over x squared plus 5.
And how about 47 while we're at it?
2x minus 3.
Okay.
Over 3x plus 5.
All right, Matthew, remember what we said to do yesterday. Any ideas?
You divide by the biggest degree.
Divide by the biggest degree. So the biggest degree here is x squared. So we take each term, x, divided by x squared, plus 1 over x squared, divided by x squared over x squared, plus 5 over x squared. So take your highest degree, divide each term by that. Now, go away. Simplify. X over x squared is 1 over x plus 1 over x squared. Nothing I can do there. This is x squared over x squared is 1 plus 5 over x squared. So we got all that. Now you basically, horizontal asymptotes are where you plug in very big x values and very small x values. You figure out is it leveling off to a point. So you essentially let x go to infinity. Let x get really big. And anytime you got any constant over a large number, it equals what? Or it goes to what? 0. 1 over a huge number. It doesn't really matter what this constant is. Any constant. It could be a 10. It could be a 20. It could be a 30. But that's going to go to 0. This is going to go to 0. 5 over x squared is also going to go to 0. So in the end, what is that whole mess? On the top, you were just left with what? 0. And on the bottom, we're left with 1. So you get 0 divided by 1, which is 0. That is your horizontal asymptote. Y equals 0. All right, we're going to go through a shortcut. We're not going to have to divide and do this every time. Your horizontal asymptote is going to be based upon the degree of the numerator compared to the degree of the denominator. Okay? That is always going to be the case. And it's going to be written on one of the forms I gave you today. We'll go over it later in a second, but I'm going to go hit it right now. If the degree of the numerator is less than the degree of the denominator, your horizontal asymptote will automatically be y equals 0. Automatic. Okay? Because the same action will always happen. You'll end up with 0 on top and you'll end up with a constant on the bottom. Now, what did we get for our horizontal asymptote for 47? Or what did you get? Okay?
2/3.
2/3 is right. Now if we went through the same process, hopefully you went through the same process. What do we divide everything by here? What's the highest degree? X. Highest degree is x. So I take 2x over x minus 3 over x. 3x over x. What is going on? Plus 5 over x. All right, 2x over x. That becomes a 2. Minus 3 over x. And then I get 3 plus 5 over x. Well, what happens as x gets really big? What happens to 3 over x? That becomes, or goes towards 0. This goes towards 0. So really, what are we left with? 2/3. All right, here's your rule. Maybe you've already figured it out. If the degrees are the same, what's going to be the case?
The coefficients.
It's going to be the coefficients. Degrees are the same as the coefficients. The degree of the numerator is smaller than the degree of the denominator. It's always going to be 0. If the degrees are the same, it's going to be the coefficients. So if I got, and I'm just making this up, g of x equals 7x squared over x minus 3 times, that's a 3, 2x plus 5, okay? You would have to understand that the denominator is x squared, right? What would be that horizontal asymptote?
7/2.
7/2, 7 over 2. Does that make sense? Okay. All right. Let's go to your guided notes. All right. You need them both. You need them both. And the first one, well, the one without the problems on it, it says definition, vertical and horizontal asymptotes at the top. We've done that. All right, and it talks about asymptotes of a rational function. Vertical asymptotes are just the zeros of the denominator. That's where it says number 1 there. You are very familiar with that. Number 2, it gives you the 3 cases. Well, we've talked about 2 of them. There's 3 of them. You're only concerned about the degree of the numerator compared to the degree of the denominator. They let n be the degree of the numerator, m be the degree of the denominator. They say for part A, if n is less than m, y equals 0 is our horizontal asymptote. If n equals m, the degrees are the same. then it is the fraction of the leading coefficients. But what if n is greater than m? Make sure we're all reading the same thing. What does it tell us? If n is greater than m, then the graph has no horizontal asymptote. It does have an asymptote, but not horizontal. And we'll get into that, not today, but we'll get into that. And it says in parentheses, if the degree of the numerator is exactly one more than the degree of the denominator, then the graph will have what's called an oblique or slant asymptote. Okay, it'll be basically a diagonal line. Okay, we'll find that using long division. All right, read through that bottom real quick. It says guidelines for graphing rational functions, just to yourself. And this is what we're going to be using today to solve these. And it's still frozen. And while you're doing that, I'm going to see if I can restart this because no, I can't because I'm recording. Number one, find and plot the y-intercept. And a lot of these say if any because you're not guaranteed to get all of them. By evaluating f of 0. That is never ever change. You let x equal 0, plug it in, you get your y-intercept. Find the zeros in the numerator by solving the equation p of x equals 0. Well, p of x is just your numerator. Those are your x-intercepts. Find the zeros in the denominator. Those are your vertical asymptotes. And then we're going to do the horizontal asymptotes, which we just talked about, and then sketch that. 1 through 4, those are all interchangeable. You do not have to go in order. And I actually like to go into a different order. So 1 through 4, it doesn't matter. Once we get those, then we go to number 5. We're going to plot at least one point between and beyond each x-intercept and vertical asymptote. I'll explain what that means too. And then use smooth curves to complete the graph. Our goal is you got to be able to graph this without your graphing calculator. Okay, you can use it to check it, but you're going to have to be able to plot points, plug it in, and understand the behavior of the functions. All right, so for this first one, and you notice I do go in a different order. I like to find my asymptotes first, x-intercepts, y-intercepts. It's all interchangeable, just personal preference. And actually, vertical asymptotes, what step is that? If you looked at that sheet, it is step 3, isn't it? All right. Do you know how to find vertical asymptotes? Essentially, Justin. Where x equals, what makes the denominator equal 0? What would it be in this case? So x equals -1. And you have to write x equals. You cannot just put -1. You cannot put an ordered pair. It is an equation. All right, that is a line. We're going to graph it. It is a dotted line. It is not solid. And I need to put it on -1, not +1. So make a dotted line there. That is going to cut your graph into 2 pieces. One piece to the left of it, one piece to the right. You cannot cross. You cannot hit a vertical asymptote. All right, horizontal asymptote. The degree of the numerator compared to the degree of the denominator. Are they the same? Yep. So what do we look for? Leading coefficient. So as you look at this, Aiden, what do you think?
It's 2.
Yeah, there's going to be 2 over 1. So now it's going to be y. Y equals 2. Okay, and this was actually step 4, I believe. Step 4. So y equals 2, horizontal asymptote, dotted line. That means as it goes to the right, we're going to get closer to that line. All right, x-intercepts. All right, these two are, well, x-intercept is missed the most. Numerator equals 0. That's what will make the whole thing equal to 0. What number, when you plug it in, will make the whole thing become 0. Okay, that is where your numerator equals 0. All right, now I'm actually going to go down below here. And so that is 2 times, what is that? X plus 3. Oops. Yeah. And now you can probably look at it and tell me, yes, I know that. 2 times x plus 3 equals 0. Distribute. 2x plus 6 equals 0. subtract 6, and we better get -3. All right, list that as an ordered pair. -3, 0. That I am going to plot. Okay, it cannot hit the x-axis anywhere else. After you solve that, you figured it out. It doesn't give us anything else. That is the only point it will hit the x-axis. We don't know whether it bounces there or cuts through, but we know it touches there. All right, y-intercept. And this goes back to, for 8th grade algebra or 9th grade algebra. Let x equal 0. All right, what do you get when you plug in 0? All right, and that's the same thing as f of 0. All right, well, what do you get? 6? All right, you get 6. So, the 2. Blame it on the 2. So 0, 6. All right, plot that point. 1, 2, 3, 4, 5. All right, we don't really have enough to really see what's going on here. You got 2 points. That's it. All right, here's the next thing you got to do. You have to do a table. In this table, we'll have a minimum number of points. Sometimes that minimum number is 2, sometimes it's 3, sometimes it's 4. All right, according to step 5, what does it tell us to do? This is where you got to understand the directions. It says pick points that are between and what? Beyond. What's beyond me? Pass it to the left or to the right. So the furthest, it's either the x-intercept or the vertical asymptote. The furthest one, I'm going to put a couple things on here I'm going to erase because I can. So just don't write this down. -3 is the furthest to the left. I got to pick a point beyond that. Okay? Any point, any x value. I got to pick an x value between the vertical asymptote and that x-intercept, and I need to pick one more point beyond there. So according to this, how many points do I need to pick? 3. Minimum of 3. And it really doesn't matter which points. I prefer, like, if this is my point, I'll try to go two away from it. It doesn't have to be. It can be 1 away. Just depends on what you get back. So I'm going to pick 1, 2, 3, 4, 5, -5. I'm going to pick in between here. I got one option, -2. That one option, that's an integer. You can pick fractions as well, okay, if need be. And then we already have the y-intercept, which does give us a lot of information, but I need another point just to feel more confident. So I am going to pick the point 2. All right, plug those in. If you get a fraction, you can leave it as a fraction. It's not a big deal. You're not always going to get nice numbers, and actually rarely you get nice numbers. All right, see what you get though. Well, again, what is it? -5, -2, and +2. And here it's really, really important that you triple check your answer, especially the sign of your answer, because if it should be a negative and you get a positive, it really messes things up. And if things don't look right, you really got to double check what values you got back. All right, so if I plug in -5, and you correct me if I'm wrong. -5 plus 3 is -2, so I get -4 over -4. Do I get 1? +1? All right, so we get +1. If I plug in -2, -2 plus 3 is 1, multiplied by 2 is 2 over negative, so I get -2, right? Okay, so I got -2. And what do I get when I plug in 2? Matthew, what'd you get for 2?
Oh, I didn't plug in 2.
What, you just doing your own stuff here?
Oh, I did 1.
You did 1. All right, Aiden, what'd you plug in? plug in 2?
Yeah.
What'd you get?
I got 7/3.
7/3. We agree with that? I'm not seeing any. I got a no.
I think it's 10/3.
He's got 10/3. Aiden, you had one job. One job. Yeah, I'm gonna say 10/3.
2 plus 3 is 5. 5 times 2 is
There we go. Good work. All right, 3 1/3. Plot those points. Right now, those are good points. Plot them, and then I want you to think. Can you finish it from there?
No, I don't know what I did.
Horizontal
okay. It's okay. We know that.
and the vertical. All right, so I got -5 1. 1 2 3 4 5 1. -2 -2, and then 2 3 1/3 or 10/3. All right, you have enough with what you know about asymptotes and what you know about the graphs to finish this off. All right. That's got to be positive. Okay, positive. All right. What happens around the vertical asymptote? What has to happen around the vertical asymptote? It has to either go towards positive infinity or it has to go towards negative infinity. It can't do anything else. What has to happen way to the left and way to the right? It has to go towards the horizontal asymptote. It cannot hit the x-axis in any other place, so it cannot hit this point and like bounce up or do anything goofy. It has to be a smooth curve. So since to the left, it has to go towards this horizontal asymptote. I'm going to start here. I'm going to go through these points, and it's going to have to go down towards negative infinity. Okay, you got to have that piece there. And it will not go up above that horizontal asymptote right now. Okay, it will not. So make sure it's clear that it follows along. All right, what's happening on that other side? Now, it does hit the y-axis, and it will cross over the y-axis, but then it will travel towards positive infinity. So it's going to look like this, and then this piece here has to go towards horizontal asymptote. So that's what your graph's going to look like. What's your domain? What's your range? Domain is everything except what? -1. So negative infinity to -1 union -1 to infinity. All right, the range. It can hit the horizontal asymptote, but it doesn't always. So you always have to look at it a little bit closer. This one does not cross over. So on the right-hand side, it stays above 2, and on the left-hand side, it stays below 2. So it doesn't include 2 in our final answer. So our range is everything but 2. Negative infinity to 2 union 2 to infinity. Okay. All right, let's take a look at number 2. Let's get through that one. You do 1 through 4. Do what you're comfortable with. If you think you're really good and you want to plot them, fine, but then just kind of hold up for a second. So find all that. To find the vertical asymptotes, what do we need to do? The denominator. Justin, question.
Yeah, they use search.
Yeah, correct. So factor that denominator. See what you come up with for everything. If you're not sure, just pump the brakes, and we'll catch up with you here in a minute. All right, so let's take a look at what you got. All right, you factor. And we get negative 3x, and then we get x minus 3 times x plus 2. So vertical asymptotes would be x equals positive 3, and then x equals negative 2. I'm going to go ahead and draw those in there. Horizontal asymptote. Degree of the numerator is less than degree of the denominator. Automatically what? 0. Y equals 0. Now, I don't think we've had one. Well, we haven't graphed one with y equals 0. All right, how do you draw a dotted line over top of the axis? You draw what we call crosshatches, where you just do little marks to indicate that that's a horizontal asymptote. X-intercept. What happens when you let the numerator equal 0? We get what? 0, 0. And what happens when you plug in 0? We get 0, 0. So the x-intercept and the y-intercept are the same point. Also, if you plot this point, it hits the horizontal asymptote. That's fine. That happens. So this is a case where it does touch or cross the horizontal asymptote. It just tells us what's going on, way to the right, way to the left. All right, between and beyond, I got to pick some points. Between and beyond. The furthest point on the left is a vertical asymptote at negative 2. I need something beyond it. Negative 4. In between negative 2 and 0, I need a point. Negative 1. In between 0 and 3, I need a point. You can pick 1 or 2. It doesn't matter. I'm going to pick 2. And I need something beyond 3. I'm going to pick 5. All right. Let's just kind of go through here due to time pretty quick. So negative 4. I like to plug it into the factored form. Doesn't matter. Okay. So let me just do this on the side, and then I'm going to erase it. But if I plug in negative 4, negative 3 times negative 4 is 12. Negative 4 minus 3 is negative 7. And negative 4 plus 2 is negative 2. So what do I get? I get 12 over positive 14. What's that reduced to? 6 sevenths. Again, double, triple, quadruple check the sign of your answer. If things do not look right, you probably got a sign on. All right, let's plug in negative 1, plug in 2, plug in 5. Let's see what we get. Here, you guys plug in negative 1. This group, negative 1. You guys here in the middle, plug in 2. You guys over here on the end, plug in 5. See what you get. So we can get this done. All right, what'd you guys get for negative 1? What'd you get, Matthew?
I got negative 4/3.
You get negative 4/3.
Negative 3/4.
Negative 3/4.
Negative 3/4.
Oh, that's what I meant. Did I say 4/3?
That's what you meant.
I do need those gloves on me.
We agree with negative 3/4? Okay, how about 2? What'd you guys get, Brandon? Did you plug it in?
Yeah, 3/2.
3 over 2? 3 over 2? 3 over 2. All right, how about when we plug in 5? Hayden?
I got negative 15 over 14.
Negative 15 over 14?
Yep.
All right, good. Negative 15 over 14. All right, let's plot those points. Negative 4, 6 sevenths, which is almost 1. Negative 1, negative 3/4. 0, 0, 2, 3 halves. And then 5 and negative 1, 2, 3, 4, 5, negative 15 over 14. All right. From these little bits of information, we have enough to figure out what's going on. Now, when in doubt, if you're, that's a negative. When in doubt, you can always plot additional points. Like you say, I'm really not sure what's going on. I want to plug in negative 5, or I want to plug in 1. You can plug in, negative 1/2, whatever helps you out. But we do have enough information because of what we know about asymptotes. It cannot cross the x-axis anywhere other than 0, 0. Cannot touch it. So that means this little point here everything has to be contained above it. It has to go towards positive or negative infinity near the vertical asymptote, so it cannot like hit that point and go down. All right, what's going to happen here? So we're going to get something like this. It's going to snake through those 3 points. And since I got, one below, one on zero, one above, it has to hit all three. And then what do you think that little piece on the right is going to look like? Yep, it's going to go towards zero, but it's also going to come from negative infinity. Domain? Everything but what? -2 and 3. Negative infinity to -2 union. -2 to 3 union. Three to infinity. All right, what about the range? Look at that middle piece. Middle piece goes all the way from negative infinity all the way up to positive infinity, right? Does it go through zero? Yeah, so it's all real numbers. Negative infinity to infinity. This is a case where it hits and crosses the horizontal asymptote. When you plug in zero, you get back zero. It's not undefined. All right, I knew we wouldn't get done with all of these, but I do want you to do 2 problems, 2 graphs, 59 and 63. Follow this format. If you get graph paper, great. If not, just make sure you're neat on another sheet. Spread it out. Don't give me a tiny graph. Okay. Give me something they can at least look at. So follow those steps. Just those two. Just those two. Nothing else. Okay. Do not do any of those or that one. Just want you to be familiar with the. All right. Good work.